So in today's calculus lesson, we're going to talk about higher derivatives in section 3.8. So the first screen, I want you to notice what the different options for our notations are. So our higher derivatives are when we go further than our first derivative, which we've been working on all the way through today. So when we're using function notation, notice that they use that prime value. So our first derivative is represented by f prime of x. Our second, we just add another prime, f double prime, f triple prime. After that, then they start using numbers. We won't, in calculus 1, we won't get beyond our third derivative, but you can see that it continues to repeatedly take a rate of change of a rate of change of a rate of change. So if I'm using just the y notation and I'm using the prime with the y, it works the same way. So the derivative of y being y prime or y double prime or y triple prime, then after the third derivative you start using 4. Now if you're using the dy dx notation, note how they're writing the second derivative. So they're writing it as d of 2, so the delta looks like it's being squared. It's not really being squared, but that's the notation, d of 2y over d of x to the second, which again, it looks like it's an exponent, but it's just showing you that this is the second derivative and the placement of it. And then the third derivative and the fourth derivative and so forth. Of course, in Calc 1, we're not going to go beyond our third derivatives. So we're most likely to be using one of these 3 notations here. All right, so let's start to work on these. So our first example asks us to find the third derivative of this polynomial function. So if it's a polynomial function, everything is just using the power rule, so it makes it nice and simple. So here's our original function. So I'm going to find my first derivative by using the power rule. So I have 3x squared minus 8x plus 3. Then my second derivative, I simply just start over. Now I'd need to simplify that if it needed simplified, but we're good to go. So my second derivative becomes 6x minus 8, and the derivative of 3 being 0. And then my third derivative, so I do f triple prime of x, would simply just be 6. So you can see in utilizing the power rule, every time I take a rate of change, my degree drops down by 1. So you can see the first derivative, the second derivative, and the third derivative. All right, so let's look at an example that uses trigonometry functions. So this is if f of x is equal to x times the sine of x. They want us to find the third derivative of pi. So I'm not going to worry about that pi till the end. I'm going to plug that in at the end. So the first thing I'm going to do, I'm going to need the product rule for my first derivative, and then I'm going to have to clean that up. So I'm going to do the first times the derivative of the second plus the second term times the derivative of the first, which is just 1. All right, so that's just x cos of x plus sine of x. All right, so now let's move on to find our second derivative. So I'm going to have to apply the chain rule again here. So I'm going to have first times the derivative of the second. So that's going to give me negative sine. I'm going to put that negative in front of there. So I'll have negative x sine of x plus the second term times the derivative of the first, which is 1, plus the derivative of sine, which is cosine of x. Now in this problem, or this derivative, I can see that I can simplify before I move on, and it'll be easier for me to do that. So that gives me negative x sine of x plus 2 cos of x. Now I need to do one more time. So one more time finds me the third derivative, and once again I'm going to have to use the product rule here. So I'll have first times the derivative of the second plus second times the derivative of the first, which would be -1. Then I have plus 2 times the derivative of cosine, which is negative sine. So I'm going to throw that negative in front again. Okay, so if I have a negative sign here and a -2 sign here, I can simplify that to be -3 sine. So my third derivative cleans up to be -x cos of x. I have -1, -2 sine, so I have -3 sine of x. Now I need to go ahead and apply this portion here where I have to find the third derivative of pi. So I'm going to go ahead and plug that pi in for all of my x's. That's going to give me -pi times the cosine of pi minus 3 times the sine of pi. All right, so if I need to remember what pi is, I can use my two sine and cosine functions, knowing that pi is right in the middle. So negative pi, so what I have here is -pi. The cosine of pi is going to give me -1 minus 3 times the sine of pi gives me 0. So that's going to disappear. So my third derivative of pi is simply going to be pi once I plug that in. Now, we could utilize that by finding different things, but my third derivative of pi right now is simply pi.